Okay, first, thank you to SME for inviting me. They saw me at AeroDef a few weeks ago, and I guess they liked what they saw. So they invited me back for an encore presentation of what I hope will be informative, perhaps entertaining, and I hope inspiring, because the advantage of speaking after others, although we're in the final stretch of the afternoon, is that I can build on what they have already shown. And I think that what you'll see today builds on what other people have already talked about, so it layers another coat of paint on your knowledge today. And I also want to thank Dynetics for hosting this event. I think it's wonderful to have this these events so that ideas are shared, and industry, government, and the military can get the best ideas and move them forward as quickly as possible. So, speaking about technology, I'm using a new presentation system. This is Prezi, but a beta version which uses augmented reality. So you'll see me inside the presentation. So hopefully this all works. They gave me the permission to try this out. So I'm going to talk about three specific things that I think will resound with most of you. The first is that artists and science fiction movies basically have invented everything that we're talking about here today. So, and I'm going to prove that in some segments of videos that I'll show you of movies. Second is that we live in a veritable renaissance of technology. The fact that we can think about designing something on a machine, on a desktop computer, and printing it, thanks to the machines that we've seen today, we'll look back and say this was the renaissance of the new manufacturing age. But we're in it. We're like the frogs being boiled. We don't realize what a wonderful environment we're in today. And the third is that I think that we're talking about a whole new, and I hate to use this word, but paradigm of technology. And that's what I'll show you in this presentation.
Initiate drop sequence.
Notice the device on her forehead. 1992. That's Pierce Brosnan for those that you don't recognize him.
I never plug a program when I'm engaged. You just move the whole effect. Oh. Gentlemen, I'm thankful to say it's been 17 years since we last had occasion to use this camera.
So what we saw there was telepresence with Jodie Foster. We saw virtual reality. In 1992, one would wonder if Palmer Luckey saw this movie and over 30 years later got $2 billion from Facebook to make exactly that device. And third was the augmented reality of the glasses. So here we go. I'm in my own presentation. And I'm also recording this, so those of you who might want to get it later, I can send it to you. And what we show here is from snail mail, this curve that goes the history and evolution of remote systems. And this is kind of an academic presentation, so I'm going to give you the background here: fax, email, instant messaging, audio web. All of these, all the way to face-to-face, belly-to-belly. And we talk about communication methods and the communicating efficiency. so that we realize that there's nothing better than sitting in front of somebody and getting all of the verbal cues and the tone and the body language that we lose in those interminable teleconferences that we're all subjected to. That's going to change because now the technology allows us to do telepresence. So I can see, I can talk, I can use my gestures to emphasize the points I'm making. And we have augmented reality, which augmented reality is just the augmentation of what you're seeing by something superimposed on it. And virtual reality. So now everybody in this room is an expert and can tell the difference between these three things. And in fact, things are moving so fast that just this week I read in the Wall Street Journal that Oculus has presented Oculus Go for $200. So now it's easy to buy and test. Sorry about that. That seems to be a little bug in the beta version, but it translates to what problems are we trying to solve? And essentially the main one, which we alluded to before, the lack of qualified engineers and the retirement of that knowledge base. This is happening in the manufacturing base. It's a serious problem. The fact that we're spread out all over the world, and how do we get those people to work together efficiently and cheaply? And the increased complexity of maintenance procedures. So we have UAVs all over the world, something goes wrong, and do you want an 18-year-old kind of futzing with, something that costs millions of dollars? Maybe not. Or maybe under the supervision of somebody who's back at the base. So where's the beef? Where's the money? We solve problems faster, and Boeing did a fantastic study with a university about the error rate reduction. It goes to zero, and any of you who might be interested in that study, I'd be happy to send it to you. But what they did is assembled spars using 2x4s. One was a manual that you followed. The other one was a computer that you walked over and saw the manual in a PDF format. And the third was a rudimentary augmented reality system that showed the person how to put the pieces together. With the tablet AR, the error rate basically goes to zero. If you're building satellite systems that cost billions of dollars, one single error can make any kind of these systems cost effective. And obviously, reduction in errors, reduction in training requirements, reduction in job time, the recall instructions, and the transfer of that tribal knowledge of those people that are retiring. Basically, decreased cost and increased first-time quality. Michael alluded to these things in his presentation as well. So we have this is just a listing of things that we see as requirements for these telepresence or collaborative systems. It has to be real-time, delays are a killer, good audio, high resolution, intuitive use, ease of operation, comfort, safety for operator. It doesn't make much sense, and I'll show you later the HoloLens devices by Microsoft. They're fantastic, but they might not be available for use in an industrial environment because they cut off your peripheral vision in a factory environment. Safety of process, the duty cycle of the device so that when does it need to be charged, and the big 500-pound gorilla that's not mentioned here, which is cybersecurity. I mean, you can't even imagine having a system of telepresence without a very strong cybersecurity to make sure that it isn't hacked. So I'm going to give you a very quick tour of different systems so that this is sort of like a walk through a candy store of technology. We have the Google Glass. There's another device called RealWear that's popular now. These are basically devices that give you a checklist or some small instructions on a small screen that you have to look at kind of sideways. They're kind of uncomfortable to use for many hours. They kind of, after a while, you feel like you're cross-eyed. But they have their applications. We have the HTC Vive, the Oculus Rift for virtual reality, we all know now. And here's a very good example, similar to the ones that Michael showed. This is a company we collaborate with in France. They're actually certifying their operators. Notice that the pressure, sorry about the sound. Sorry about the sound being too loud. But the point is that that's being used today to certify gas operators before they go out in the field. So obviously the same thing can be done with any kind of complex machinery. HoloLens, everybody knows. This is a very good application of augmented reality where you see the part superimposed on your field of vision. It's kind of magic. And this is obviously a very good application if you're doing complex assembly. The problem is that building these systems requires quite a bit of time, effort, and money. And if it's something that somebody does repeatedly, it doesn't really make a lot of sense economically. But
next step, he's going to insert the slotted screwdriver blade into the impeller. Now, there's 20 different ways you can remove that impeller. The best way is exactly how we're showing it. So he's able to insert that screwdriver, tap it with a hammer, and it's going to spin it right off the end. Once again, he sees it and does it.
The reason why I show this is because try to explain that procedure in a text, in a manual. It would be impossible. So that's a very good application of the augmented reality in a procedure that somebody, if they do it wrong, will break the hammer, break the impeller, and cause a lot of problems.
She's going to help us with the HoloLens version of this now. So what I'd like you to do is, put on the HoloLens, and she's going to look at that same catalog page and see it from the HoloLens view. So go ahead. So she sees the same model. If you notice, even the changed note is there.
I don't work for Microsoft.
She's using HoloLens. She's not tethered then to this piece of paper or the catalog. She can bring this catalog to life. And so why don't you go ahead and bring this, take the loader, go ahead and put it on the stage for us.
Great, happy to trigger that animation.
This is what you see.
And what's unique about this mixed reality experience is that prospective Caterpillar customers can view the Caterpillar at true size and scale. Caterpillar, change configuration.
Oh, I like that. So when they talk about the magic of software, I think it's all right there. So hardware, software, the cloud, bringing it all together, real-world scenario.
I think what I've done is gone out and tried to find the very best examples of the different technologies. I think that that one is particularly compelling.
More and more today, people are working remotely. They're not all located in the same physical building. Imagine being able to change the people you're meeting with, the place where you're meeting, or the content that you're collaborating around, all in a matter of seconds.
It really unlocks new possibilities for the way that information worker can be productive. Inherently saying you want a PC on every desk implies that people have desks. But we know that there's a huge part of the workforce that actually don't have desks. In fact, we think 80% of the workforce are what we call first-line workers, and we think they number over 2 billion worldwide. When computers have the ability to understand the real world, a bunch of really powerful things can happen.
We've been looking at the critical workflows for the first-line worker, and we are committed to bringing products to market to help them do their jobs more effectively. One of the first critical workflows that we uncovered was for the field service worker who often needs to call in for some expert help. With mixed reality, we can bring the expert to them, and the expert can see what they're seeing and can annotate into their space and help them solve the problem and verify that's been done correctly. Another critical workflow that we've uncovered is around training employees on new products, processes, equipment. Companies are spending a lot of time and money on this today, and these things change often, and they're so critical to their operations. Another area of opportunity is around space planning. Companies need help designing and planning out their spaces efficiently. Mixed reality enables them to view their designs with digital objects, and they can see them at scale, and they can walk through them and iterate before they have to make the costly decisions.
And I think all those things come together to sort of shape what this modern workplace looks like as we go forward. Digital transformation is really impacting every industry, every company today. And the companies that we see that are most successful at digital transformation are those that empower their employees and rethink the employee experience all the way from the boardroom to the information worker and then onto the first line worker.
Sorry about the long Microsoft ad, but I thought it was also very useful to see it kind of very quickly some of the things where they're targeting. A lot of you may also know ODG. They also have a HoloLens-like device, and this is a telepresence device for ATEX or explosion environments. What's the benefit of that? That's simply telepresence, like we saw Jodie Foster in the first segment, where I can guide somebody in a explosion environment, an ATEX environment, and that person can basically be my avatar. It's a Wi-Fi camera that connects to the phone. There's another device, full disclosure, this is something that we manufacture. We said, okay, let's do telepresence because HoloLens is still only 1 hour usable. And what we want right now is something that we can use today. So what we did, and later you can come and see it, it's, well, I'll show it easier. Consists of a high definition 30 frames per second camera connected to an Android phone that goes on the arm. What we did was modify the Android operating system to accept a USB connection, which is not allowed normally by Android, but we did this in such a way that the phone is not rooted, and it works with all of the video conferencing applications, Skype, WhatsApp, WebEx. So that's a very simple $1,000 for the whole kit, if you guys want to see it later. But that enables somebody that's remote anywhere in the world to operate under your instructions with no latency. That means that there isn't that 1.5 second delay that the Wi-Fi would introduce because it's wired, so you don't have FOD dangers when you're working on aircraft. So, very quickly, implementation roadmap in your facilities. Ask for help. The people that are there, what are their problems? Get their buy-in. Start small and sell the vision. Fail fast and often because the people have to be involved in the process. Measure, measure, measure. KPIs to see if this is really worth it. What are the gains? And celebrate the collaborative success. And since I can send this to you guys later, but basically, you know, I talk about different levels of the roadmap for adoption. You know, basically offline operation, connected apps, richer information and interaction, and fully closed loop and smart interactions. I'm going to spend less time on this because I want to spend more time on what's coming and where I think that I can add value to this afternoon. So RFID is a technology that Delta is using to monitor the theft of their in their aircraft, the life vests. People tend to take them as souvenirs. And oxygen generators, they all have RFID tags. A Delta operator walks down the aisle and can do an instant inventory of everything on that plane to avoid the problems that can occur if you don't have them. drone inspection. I thought this would be useful for this crowd. This is Air France.
The drone uses laser technology to position itself relatively to the aircraft. We load the 3D model of the aircraft on the drone, and using the laser scanners, the drone can autonomously navigate around the aircraft.
It can be extended to other types of inspection, such as lightning strikes.
Like I said, I brought samples from all over. This is a very interesting application, which probably most of you already know, Predictive from General Electric, that monitors the health and performance of their jet engines in flight. Now we get to the meat of the crux of the matter. We all dream the paradigm of paperless maintenance, of airplanes that are in service 10, 20, 30, 40 years, and we want to know everything that's happened to them. Maybe in the military that might be there might be different standards, but in the commercial space, you basically still get boxes of greasy papers that have been signed off by mechanics during the life cycle of that airplane. That is necessary because the leasing companies require that documentation in order to sell the aircraft to the people down the tiers of use. But what we believe is that instead of creating virtual models, why not identify each object of the plane as a discrete object from the moment it is designed, assembled, and maintained during its entire life cycle. Each object identified uniquely and blockchain secured, like Kenneth was talking about before. And for those of you who might want more information on those subjects, please, I'll give you my business card. I have both the military and the commercial papers on blockchain use and what they call digital twin and digital thread. This is a company, Kisters, that produces real-time views of the objects. This is Boeing, and it's I think it's 1 million parts. And the advantage of using these rendering engines over Unity or RealX, which are some of the video game environments, is that this produces renders in real time. The problem with Unity and RealX is that normally you have to compile those objects so that any changes are not instantly updated. What we're talking about is a collaboration. Let's see, wait, I might have skipped something here. I'll just let that play out. This is critical for you guys, I hope, to understand, is that we're talking about a new way of thinking of complex objects. Instead of geometric shapes, we think of them as collection of individual parts. If those parts are individually determined by their supplier, then we have all of that long tail and metadata during the entire life cycle of that plane, building, refinery, whatever. Okay, let me just make sure this is done. Good. And what we're talking about is the platform for collaboration. Here we see the ants using their own bodies to traverse this obstacle. These fish are swimming together not because it looks pretty, but because by doing this they have thousands of eyes on their predators. And birds do this too, so that, it's a little loud, it's beautiful to watch.